Over the last 1 month, I've been building this DevSecOps series from scratch. Most DevSecOps series content teaches tools. This particular series teaches incidents. Over the next few episodes, we are going to simulate real world DevSecOps failures, for example, Terraform, container security, Kubernetes RBAC, secret exposure, CICD security gates. You will not just see the solution, you will see the failure, you will investigate the symptoms, you will identify the root cause, and you'll apply the fix. For every episode, I'll be sharing a free GitHub repository so you can follow along and learn by doing. I also created a premium DevSecOps production incident pack with complete lab setups, architecture diagrams, root cause analysis, interview guides, and additional learning material. Link is in the description. If you'd like access to this source code, watch the full video and comment DevSecOps below. My goal is simple: help you move beyond tutorials and start thinking like an engineer who can investigate and solve real production problems. Let's get started. Most DevSecOps content talk about tools. Install scanner, run this command. But real production problems don't happen because tools are missing. They happen because of small decisions inside real systems. Today, I'm not going to teach you a tool. I'll show you a real mistake where infrastructure was deployed successfully, pipeline was green, but production was exposed to the entire internet. If you are serious about DevOps or trying to work on real production systems, don't skip this. This is the difference between knowing tools and actually understanding how systems fail. Now, let's build this and see what actually goes wrong. I'm going to open my Visual Studio Code, and in my Visual Studio Code, I have a folder named Terraform DevSecOps Demo. I'm keeping this very simple because real problems don't need complex setups. Just one wrong configuration is enough. So, this is a very basic Azure setup wherein I'm trying to create a resource group followed by a virtual network, a subnet, network security group, then network security rule, finally network security group association. Nothing complicated, it's very simple, normal infrastructure as code. Once I write this, I can run Terraform plan. Before that, I have to do Terraform initialize. Terraform initialize is successful. Now I will try to run Terraform plan. It will try to create multiple resources. All right. Whatever resources we define in infrastructure as code, you can see very clearly it is trying to add 6 resources: 0 to change, 0 to destroy. All right. I do not see any kind of problem in the code. All right. So, as a developer, I write this code. Everything looks good for me, and I will try to run Terraform plan and also Terraform apply. Before doing that, I will create a pull request for that, and someone from our team reviews that. This is very simple. As I said, very simple code. Everything looks clean, but security is completely broken. Look at this. Destination port is equal to 22. That means SSH access. And here, source address prefix equal to star. This means anyone from anywhere can try to connect. And Terraform is completely okay with this. Because I did not see any kind of warnings. I did not see any kind of errors. Everything looked clean. But security is completely broken. Now, imagine this is deployed in production environment. SSH is open to the entire internet. Bots will find it out in minutes. You'll have brute force attacks, scanners, automated scripts, and very big, dangerous, and scary part. This particular code can easily pass code review because technically it is not wrong, and if someone is working on multiple different files, this small stuff can be ignored or missed somehow. This is the difference between infrastructure working and infrastructure being secure. Now, this is where DevSecOps actually comes in. Terraform validates syntax, but tools like TFSEC validate security. Now I'm going to show you in a moment. So, as soon as I run this, this is exactly what we missed. I can see two potential problems detected. And if I scroll up, look at this. Here, clearly it shows resource source address prefix equal to star. All right. Network security rule is the same again. Once we fix this, automatically this will also get fixed. So, two critical errors. Clearly, it is pointing out to what I was discussing. Correct? Now, without this step, this goes straight to production. This usually happens. I'm not, just saying this actually happens in real production environments. Now, instead of allowing everything, let's let's restrict access. So, source address range, I'm going to say instead of star 10 dot 0 dot 0 dot 0 slash 16. Okay. Now, only internal network can connect, not the whole internet. But this is just a fix for this particular demo. In real production, you should not blindly allow the full VNet. So for example, I'm using the VNet address here. All right. The real fix should be actually someone who needs access. The source address should be specific to a particular application or particular user, limited. Okay. Or to a subnet. You can do that as well. If you don't want to be specific, I mean, there are multiple users, subnet is acceptable. Okay. Now, see the difference. The same infrastructure, but secure. Now, let's try to run this command once again. TFSEC dot. Now, you see the difference. No problems detected. Just one simple change, small change can damage your whole infrastructure. Also, one small change in your code can protect your infrastructure in many different ways. All right. In this series, I am going to break down how different parts of a system fail. Today, it was infrastructure. Next, we will see how application layer can be insecure even when pipelines passes. This is why DevSecOps is not just about tools, it's about understanding how small decisions like this impact real systems and catching problems before they reach production. If you like this video, don't forget to like, share, and subscribe. Thank you for watching and see you in the next video. Most people think once security scanning tools are added to CICD pipelines, the systems become secure. That is completely false. Today, I'll show you a production style DevSecOps problem where the pipeline scans Docker image, vulnerabilities are detected, but deployment still happens. If you want to work on real production systems, this is the kind of thing you need to understand. Not just tools, but how security failures actually happen. If you are new to my channel, subscribe and comment DevSecOps so that I know you are following along with me. All right. Now I'm going to jump to Visual Studio Code. Here we have episode 1 folder followed by episode 2 vulnerable image. Here I'm going to write a new file application.py. This is very simple application code which I'm going to write. So here if you see, we are just creating a basic Flask application which is returning vulnerable container demo. That's it. I'm not explaining huge, I'm not taking complex applications here. The goal is very simple to make sure you guys understand DevSecOps problems. Now, I'm going to create another file requirements.txt wherein we are going to write Flask dependency which we are going to install, followed by we are going to create a Docker file. So I'm going to write a Docker file here, and in this Docker file we are going to write some code. Again, I have a full Docker Home Lab series on my channel. If you don't know anything about Docker, please go watch that and come back to this series so that it will be easy for you to understand. If you look at this Docker image and if you know Docker, then definitely you know the answer. This particular file is a problematic file. Why? Let me know in the comments what do you think, and also by seeing this file, write down what all are insecure in this particular file. So starting here from Python 3.8, okay, this is an old image, right? Python 3.8 is like a very old version. That image I'm trying to use here, that means outdated system packages, vulnerable libraries, unsupported dependencies, and many teams never update them. This is the reality. Even today, production environments try to run these kind of images due to so many different reasons. It's not like they cannot use latest versions, but due to some different dependency issues, they still use old images. Okay, now I'm going to build this image. First, let me check if I'm present in the right folder. Yes, I'm in the right folder. I can run docker build command here and we can build this particular image. So the image got built successfully. I do not see any kind of problems here. Followed by, we are going to run this real quick. For that, I'm going to say docker run port 5000 vulnerable demo colon version 1. Now, here's our first problem. So if you see, cannot import URL code from this particular name, blah, blah, blah. Okay, we came across one problem now. So how do we fix this? I know the fix because I am working on this from some time already. So I'm going to add this particular dependency, and let me build the image once again. So Docker build vulnerable demo v1. The goal is to show you DevSecOps related stuff problem. Please forget about this particular dependency issue. This is common because I'm using the old version. Now I'm going to run this real quick. So if you see, now it is successful. I'm able to run the container. Let me jump back to the browser. Now I will say localhost port 5000, enter. If you see vulnerable container demo, this works perfectly fine. Our application is running, container works. From the functionality point of view, everything looks perfect. This is the same exact code which we have in our Flask application, vulnerable container demo. But security problems are invisible at this stage, right? Did you figure out or find out any kind of security issues so far? No. Now, we are going to install a tool. I would like to run wget command to download Trivy from official website. I'm going to give you all the steps in the readme file. Don't worry about this. Followed by, I'm going to run echo dbn command. Then finally, we are going to update our system. Followed by, we are going to install Trivy. Now we are going to install Trivy. So Trivy installation got successful. I will try to run Trivy hyphen version. I can see Trivy successfully installed on our machine. Now the goal is to run this particular image using Trivy command. So I will say Trivy followed by image vulnerable hyphen demo colon version 1. We have this image built locally, so we are using Trivy tool here. Press enter. So if you see, it is trying to update the DB here, downloading vulnerability DB, followed by downloading artifacts. Then it is trying to scan now. If you see, licenses acquired from one or more metadata, and we see so many different issues here. For example, high CVE package index.py, followed by, if I scroll up, I can see medium level CVE. Okay, then if I scroll up more, I can see one more medium level, high resource consumption leading to denial. Then I see another high CVE, same related to workzook when parsing multi-part. So yeah, if you see, it found total 20, 3 low, medium 10, high 10. Okay, these are related to Python package. So if you see, we can see so many different CVEs here. I'm not going to look into details. This is expected because I'm using an old image version, right? We are using old Python image version. That's the reason we are seeing high, medium, low, all these kind of CVEs, which are very, very important because vulnerabilities got detected once we use Trivy tool. So people think security is working, but not necessarily. Because see, once we figure out this, most of the people think, okay, we have a CICD pipeline in place that will take care of the security issues, right? This is very, very common, I'm telling you. Some people, do it by themselves. I mean, they try to fix it. Some people do not even try to check locally on their machines using Trivy command. They think, okay, we have CI/CD pipelines in place. Let it test. Okay, it's not their responsibility. Some developers think it's not my responsibility. We have a pipeline in place. It will take care of any kind of CVs where we come across. So what I'm going to do now, let's create a file dot GitHub, followed by let me on the root level I would like to create this. So let me copy real quick. So I'm going to create a file here. No, sorry. I'm going to create a folder here first. Dot GitHub slash workflows. Followed by in this folder, I'm going to create security.yaml file. Okay. So once we create this security.yaml file, I'm going to write some GitHub Action CI/CD pipeline. This is again, I already explained in detail about this particular CI/CD series. I'm not going to explain once again in detail. So very high level, this is, let's say, a security scan. If you haven't watched my CI/CD series, then definitely you have to watch that to understand everything in detail. On push to the main branch, we are running on Ubuntu latest. We have a checkout step here. We are trying to build the image, and then we are trying to run the Trivy. That's it. Image reference, we are trying to give vulnerable demo version 1, table format, exit code, severity high. It will try to check for high severity issues. Also, I would like to update here. So this will run on in this particular directory because our files are in this particular folder. I don't want to run it on episode 1. So it will run on episode 2, vulnerable image. This is very important. If not, the pipeline will fail. I'm going to save this real quick. Followed by, we are going to add git commit -m add episode 2 vulnerable image. Then let's push this. So as soon as we push, we have the source code in our repository. Now let's jump back to the workflow details. And if you see, the pipeline is running right now. It did try to set up job, check out the source code, building the image, followed by, let's see what will happen next. Now look very carefully in this particular step. Run Trivy. We are using Aqua Security Trivy action, followed by, we have an image here, format table, exit code 0. Look very carefully at this particular line, exit code 0. Even if vulnerabilities are found, pipeline still succeeds. This is extremely common in enterprise environments. Security scan exists, but policy is weak. Having security tools in place does not mean you are secure. So if you look at our pipeline, the pipeline is green. It tried to check out the source code, followed by it tried to build the image, as you can see very clearly, Docker build vulnerable demo. Then we try to run Trivy. So let me scroll down. Here I can see so many CVEs, so many different problems, and we have it in a table format, as you know, we wrote in our pipeline step. I'll try to keep scrolling here, and I can see so many CVEs here. Then it try to run post steps as well. The pipeline is green, right? This is very dangerous in production environments. Security issues are visible, but deployment still happens. Now let's imagine I'm going to add another step here after Trivy. So what is the next step? So I mean, in general, once the scan is successful, we are going to add a deployment step, right? I'm just trying to show you a brief demo here. We are not actually deploying. I mean, in reality, after the scanning is done, we are going to deploy to Kubernetes cluster or maybe ECS or maybe Azure Container Apps. It can be a production VM. I mean, multiple places we can deploy this, right? I'm going to add this real quick, followed by git commit -m add deploy step git push. Now, if I jump back to my pipeline, so if you see add deploy step, the scan is running right now. Now look at the pipeline. Once again, it tried to run the application, it tried to build it, ran Trivy, and also deploy was successful, right? Most security failures are not because scanning is missing, this particular step, scanning, they happen because thresholds are weak. Teams ignore all these findings. Pipelines prioritize delivery speed. Temporary exceptions become permanent. Majority of the teams try to add exceptions saying marking it as temporary, but they become permanent. This actually happens in real production enterprise environments. Okay, I'm stressing it because I've seen this from my own experience. That's the reason I'm trying to teach it here as well. So how do we fix it properly? I'm going to jump back to the Visual Studio Code, and here instead of exit code 0, I will add it as 1. Very simple minor change. All right, followed by critical comma high. Okay, we are making it more stricter here. I'm going to save this file, and then let's try to add this real quick. Git add git commit -m update pipeline, followed by git push. Now let's jump back to the pipeline once again. Now let's look at the difference. As usual, it is trying to check out the source code, building the image, followed by it will try to run Trivy once again. The pipeline failed with an error. Looks like I made a simple mistake. Let me jump back to the Visual Studio Code. Yes, I have a space in my severity critical comma high. So let me add that real quick. Git commit -m remove space. Then I'm going to push this real quick. The pipeline started running once again. Now pipeline fails if dangerous vulnerabilities exist. So this is exactly what we changed. So if you see, we have so many vulnerabilities. So that's the reason the pipeline failed and it did not proceed to deploy step. Now security becomes enforceable, not just informational. So if you see, previously it was passing, we had a green pipeline, successful green pipeline. Now we have a failed pipeline. Wantedly, we added exit code 1 because we want to fail our pipelines if there are any vulnerabilities. This is how we add strict policies within the pipelines so that the pipelines will not go green, and also we are not going to deploy it to production. Now we are going to update this base image with Python 3.12, followed by we are going to update the dependencies as well. I'm going to remove all of this and I'm going to add Flask 3.0.0 here and follow the same process once again. We are going to build this image. Again, we are going to run this and push it to the pipeline. And also we try to scan it locally using Trivy, always make sure you're updating your base images regularly because it is very, very important. Many vulnerabilities disappear simply by upgrading this base image. So once you update to the more latest version of the image, it would be little bit much clearer than the old 3.8 version. I mean, you can see issues with this particular image version as well. We have a different concept of, wherein you will not have any kind of vulnerabilities. For example, Docker hardened images. I don't want to go into details of that, but for this episode, I want to keep it simple so that you understand what I'm trying to explain and what kind of problems we see in real production environments. So, in episode 1, we saw insecure infrastructure. Today, we saw insecure containers. Next episode, we'll look at how Kubernetes RBAC mistakes can expose the entire cluster. This is why DevSecOps is not just adding scanners. Security only matters when policies are actually enforced. Otherwise, pipelines become security theater. Thank you for watching and see you in the next video. Most DevOps engineers think if Kubernetes deployment is successful, the system is healthy. Pods are running, service is reachable, CICD is green, so everyone relaxes. But today I'll show you a real production DevSecOps problem where everything looked completely normal while security was completely broken. If you want to work on real production systems, this is the kind of thing you need to understand, not just Kubernetes commands, but how production systems silently fail. If you are new to my channel, like this video, comment Kubernetes so that I can send you the full source code. Now, let's build this step by step. I'm going to jump back to my Visual Studio Code. Here, we already did episode 1 and 2. Now I am going to create another folder called episode 3. I will say episode 3 Kubernetes RBAC risk. So this is all about RBAC. I'm going to explain in detail. Stick around till the end. I'm going to keep this setup very simple because real production incidents usually come from small operational mistakes, not huge complicated architectures. First, I'm going to create a Python file app.py. So in this file, we are going to write some code, very, very simple once again, like we did in our previous episodes. So if you look at this particular code, here I am trying to expose environment variables directly in the response. Never do this in production, but mistakes like this happen more often than people think. Many people just do it for testing purposes and they push all of this to GitHub repository. Followed by, I'm going to create requirements.txt file, and in that I'm going to add Flask. Very simple, as I said. Followed by, we are going to create a Docker file. So again, Docker file we already did in our previous episode. I already explained If you haven't watched that, please go watch that video as well. So this is again the simple Docker file wherein we are trying to create a user, copy the requirements.txt file, installing all the stuff, and also trying to run the application. Now let's try to build this image real quick. For that, I'm going to use Docker build DevSecOps -k8 version 1. Press enter. The image is getting built right now, followed by we are going to create a insecure deployment.yaml file. The image is ready now. This looks normal. Everything is fine so far. Now I'm going to create another file called deployment bad.yaml. Okay, so in this file I'm going to add some deployment code. So this is very simple deployment. Once again, insecure app name followed by the container name we are trying to give here. Then image would be DevSecOps K8 colon version 1, which we built just now. Followed by, if you look here carefully, this is the very dangerous part. We are hard coding production secret directly inside deployment YAML file. Okay. Now, Kubernetes will happily accept this. Deployments will be succeeded, but security is already broken before we even do anything. Followed by, I'm going to create this service real quick. In the same folder, we are going to create this service file. I will say service bad.yaml, and in this file, I'm going to expose it to the node port 3080. Again, I mean, Kubernetes is completely okay with this. Now we are going to load the Docker image into the cluster so that we can deploy the YAML files. First, we are going to start with deployment.yaml file. I'm going to run kubectl apply command here, followed by we are going to create the service bad.yaml file. kubectl service got created, deployment got created. Now let's try to run kubectl get pods. Press enter. If you see, pods are running fine, right? Also, let's try to run kubectl get svc. Press enter. This also looks good. Our pods are healthy, service is reachable, deployment succeeded. So many engineers stop troubleshooting here, but in reality, security is broken. Now let's try to run kubectl port forward insecure service, followed by I'm going to jump back to the other terminal. In this terminal, let's try to run curl http localhost port 8080. Press enter. Now look at this very carefully. Application is running. Environment we can see. Database password as well. It's completely visible in production environment. We just exposed internal secrets publicly. Attackers don't always need complicated exploits. Sometimes applications expose sensitive information directly because of poor deployment practices. Kubernetes in itself is healthy. So kubectl get pods, this is healthy. CICD pipeline is also healthy. Monitoring may still show green, but security is completely broken. Infrastructure health does not equal to security. Now, this is already dangerous, but The real problem is something much worse. I'm going to create another file, name it as RBAC bad.yaml. So in this file, we are going to add some code once again. So what exactly we are trying to do here? This is the service account which is supposed to deploy application. Normally in CICD pipelines, we use service accounts, but someone gave cluster admin permissions. Usually this happens because deployment was failing for some reason. Permissions were annoying. I mean, this actually happens in real production environments, and engineers wanted a quick fix. Okay, as an engineer, you want to fix the issue real quick. You will give cluster admin access just for testing purposes. Now I'm going to save this, followed by, let's try to apply this real quick. I'm going to say kubectl apply -f rbac bad.yaml. Press enter. If you see service account created, RBAC authorization created with CICD deployer admin. Now I will say kubectl auth, can I get secrets? It says yes. Now the CI/CD pipeline can read secrets from the entire cluster. Also followed by, I will say, can I delete deployments? I get a yes again. If CI/CD gets compromised, attackers get these permissions. Now attacker can read secrets, destroy workloads, modify our deployment files, access namespaces. This becomes a cluster-wide security problem. So how are we going to fix this? For that, I'm going to create a new secret.yaml file. In this file, I will give my actual password information. So for example, if you see here, I'm going to give it a name, secret, and string data db password. Now I'm going to kubectl apply secret.yaml. Secret got created successfully. Now this is better than hard coding passwords directly in deployment.yaml file. But in real production environments, many companies don't manually create Kubernetes secrets like this. Usually secrets come from Azure Key Vault, AWS Secret Manager, HashiCorp Vault, because Kubernetes often integrates with external secret systems. So instead of developers manually creating secrets inside the cluster, applications pull them securely from centralized secret management platforms. Because once secrets are manually copied everywhere, they become difficult to rotate, difficult to audit, and also difficult to secure. Followed by, we are going to create a new file, deployment fix.yaml. So in this file, I'm going to add the exact code once again with reference to the secret. Name db password, value from secret key reference, application secret, which we already created here. So instead of hard coding it, I am going to add this in our deployment.yaml file. Now the password is no longer hard coded directly in the YAML file. But this alone is not enough. Kubernetes secrets protects how the value is stored and injected. It does not protect you if your application prints the secret back to the users, right? So I'm going to create another file named rbacfix.yaml real quick. So in this file, we are going to explicitly assign the permissions. So for that, I will say here I'm going to add deployment permission. For example, get, list, watch, create, update, patch. So these are the kind of permissions which we are going to assign, and here the deployment manager role reference we are trying to give. Now let's try to run kubectl RBAC fix.yaml. Press enter. Now if you see CICD deployer safe created, deployment manager created, deployment manager binding created. Now once again, if I try to run kubectl auth, can I get secret? Press enter. Now I get it as no. Previously we were getting it as yes. Now the CICD service account only has permission it actually needs. It does not have the full cluster access. Once this is done, I'm going to jump back to the application code, and in this code, I'm going to update this real quick. So previously we had this exposed. Now I'm going to say application running securely. Save this real quick. Followed by we are going to build this Docker build DevSecOps K8's version 2. Then we are going to load this image into the cluster. Followed by we are going to set this image into the deployment. Press enter. Image got updated successfully. Finally, we are going to do a rollout. kubectl rollout status deployment insecure app. Press enter. Successfully rolled out. Finally, let's try to run the port forward once again. Now, let's try to access it. Curl localhost colon 8080. Now you see application running securely. Same Kubernetes deployment, but production safe. In episode 1, we spoke about insecure infrastructure. Episode 2, we saw vulnerability containers. Today, we saw how Kubernetes deployments and RBAC mistakes can silently create massive security risk. Next episode, we will look at how production secrets leak through CICD debugging. This is why DevSecOps is not just about scanning tools, it's understanding how security failures happen inside normal operational workflows. Most production incidents don't happen because systems are down, they happen because systems are insecure while still looking healthy. Thank you for watching and see you in the next video. One dangerous thing about production incidents is that security controls usually break during pressure situations. Imagine you are working in a production environment and deployments start failing, everyone wants logs, pressure increases, and teams start enabling emergency debugging. Today, I'll show you a very realistic DevSecOps incident where troubleshooting a production deployment accidentally created a security problem. If you work with CI/CD pipelines or production deployments, this is something you absolutely need to understand. Now, I'm going to create a file Python, very simple once again as we did in our previous episodes. I'm going to write some simple Flask application code. The focus is not application development here. It's around operational pressure around deployments. Followed by, I'm going to add requirements.txt file real quick. Requirements.txt file. And in this file, I'm going to add Flask. Followed by, we are going to create a Docker file. I mean, it's the exact same setup which we had in our previous episodes. If you are following from episode 1, definitely you will relate to this episode as well. So I'm going to go back to my Docker file. This is, let's say, a production grade Docker file. I'm going to copy this exact file and write it down here. As I said, the goal is completely deployment perspective. That's the reason I'm not going to explain in detail about this particular Docker file as well, because we already did that in previous episodes. First, I'm going to, right now I'm in this particular directory. I'm going to build this Docker image real quick. So I'm going to say Docker build production debug demo version 1. Press enter. So we have built the image successfully. I did not come across any kind of problem so far, correct? Followed by, what exactly we are going to do? Here in the workflows.yaml file, I'm going to create a file name deploy.yaml. In this file, I'm going to write some workflow.yaml file. If you see, again, it's very simple. Production deploy followed by pushing it on main branch. Then we are trying to run on Ubuntu latest. Working directory would be episode 4 production debug incident. Environment would be prod, and this pipeline has API token from GitHub secrets. I'm going to show you that as well. Followed by, we are trying to check out, build the Docker image, and trying to deploy the application. Very simple. I'm going to save this and let's try to run this. Git commit -m add episode 4 folder push. Now I am in the GitHub UI. I'm going to click on this pending and I see production deploy pipeline is running. By the time it runs, let me jump back to the settings, and in the settings we have environments. So I did create this environment prod with a secret. So I'm going to click this. You can see API token. It was created some time ago. Just for this demo purpose, I created this token. Followed by, let's jump back real quick. I'm going to look at the pipeline and the pipeline is failing. Setup job, checkout step, building the Docker image. The pipeline is failing and I do not see any kind of more information of what exactly is going on with the pipeline. Now imagine this in real production environment. Releases get blocked, teams are waiting, you get messages everywhere from emails, from different channels. Everyone is asking you what's happening. Now we are trying to simulate this particular failure. Instead of stopping the entire pipeline immediately, we are going to continue the debugging step. So previously we had only deploy application and we were trying to run this. Now I try to add an ID with a deploy continue on error equal to true. That means if the pipeline fails, it will try to continue with the next steps. After this step, emergency debugging starts automatically. If steps deploy.outcome equal to failure. If this is failing, we are trying to define this particular step here. Run echo deployment fail and try to write it to the debug.log. Then once again echo starting emergency debugging. We are trying to add this to the debug.log file. So after this, we are trying to run curl -v command with authorization token and the URL followed by we are trying to write everything into this particular debug.log file. This is very common. Engineers enable curl-v verbose logging during incidents all the time, so that this particular command will help you with request details, headers, authentication information. That means basically everything. At this particular stage, nobody is thinking about security anymore. They want production fixed as soon as possible because of pressure. Now, all the debugging which we are trying to do is being written to this particular debug.log file. And this is where incidents quietly begin. Because after this particular step, we are trying to upload the same debug.log as an artifact. If you see here, upload debug logs, if always, with name debug.logs, path would be in this particular location if no file found error. Now, according to this particular step, the debug.logs are being uploaded as artifacts. Why are we uploading it? So that multiple engineers can inspect that quickly and resolve the production issue as soon as possible. This is completely normal operational behavior. At this particular point, deployment issue is already understood. Teams relax, incidents look under control. Now, let's try to add this and try to run the pipeline real quick. Git add git commit -m followed by update pipeline with debugging step. Git push. Production deploy was successful. I'm going to open this real quick and I can see the green pipeline now because Docker build was successful, deploy application was successful. It got an error. We enabled emergency debugging here. So I can see debug.log here, followed by uploaded debug logs. Also, if you see, I can see artifact download URL. I can click on this link. It tried to download this for me. I'm going to quickly open this particular log file. Now, this is our log file. If you see, clearly everything is written in this particular log file. And if you scroll down, now look at this authorization bearer and the password token. Production API token is now stored inside CICD artifact. This is an artifact. Now, anyone with this particular artifact access can easily retrieve deployment credentials, production API access, internal system access, depending upon what this particular token can control. This was not malware, not sophisticated hacking, just operational pressure. And if this particular token also had Kubernetes permissions like we saw in episode 3, this incident becomes much worse. Now, let's look at the pipeline once again. Instead of writing curl-v, I am going to replace this with silent -fail. And sensitive logs should never be uploaded blindly as artifacts like we did here. Majority of the teams try to do that. Mature production systems usually combine restricted artifact access, secret masking, short-lived credentials. Now I'm going to add this real quick. Commit -m update pipeline git push. Just to show you the difference between curl-v versus silent fail. The pipeline is running and I can see it is already success. Let's look at the debug.log. I'm going to open this. Now look at this. We have very less information in this particular log file, and also the secrets are not being exposed clearly. This is how you need to have controlled behavior. Most production environments are not compromised by one giant mistake. They are compromised by many small shortcuts during stressful situations like we discussed today. Healthy systems can still be insecure systems. Thank you for watching and see you in the next video. This deployment should never have happened. SonarQube found the issue, the pipeline saw the scan, but deployment still continued. And this is exactly how many companies create a false sense of DevSecOps. They add tools, they add dashboards, they add multiple different scanners, but security findings don't actually stop unsafe releases. Today, I'll show you the real difference between using SonarQube and actually enforcing SonarQube. First, we are going to start with the SonarQube setup. Here, I already created episode 5 folder SonarQube Quality Gate. In this folder, I already created multiple files: application.py, Dockerfile, SonarQube project properties. All of these details we are going to write down in this particular video. And also I created some workflow files: SonarQube bad.yaml, SonarQube fix.yaml. First, I'm going to connect to the remote virtual machine. So this is where my GitHub actions also running. So we are doing a self-hosted runner so that we can easily connect to our SonarQube server. First, I'm going to start with Docker command. So Docker run --name SonarQube followed by the port 9000, and I'm using the community version of SonarQube here. Press enter. Just give it a minute or two so that our server will be up and running. If you immediately try to access, you might get not reachable error. So let's wait for a minute or two, then we can access the server. Now let's access the SonarQube server. Looks like our server is ready now. I'm going to log into that server. So let's use the default admin password, and followed by we have to change the password. So I'm going to give the old admin password followed by a new password. All right, I am updating the password now. So the password got updated. So if you see, this is how our SonarQube dashboard looks like. Not dashboard, yeah, homepage we can say. And here you can see projects, issues, rules, quality profiles, quality gates, administration, and we have some other information as well. First, we are going to create a project here. So I'm going to create a local project. Let's start with that. So just click on this project and I'm going to give it a display name. For example, we are doing episode 5. So I'm going to write episode 5 SonarQube Quality Gate demo, and project key, let's leave it as it is, followed by main branch. Okay. Once we have that, I'm going to click on next. So here we are going to follow the instances default. Is custom, this is let's say majorly used in our production environments, we are going to compare new code quality against the previous project version and also focus on newly added code. Let's keep it simple. So I'm going to click on create project. So now we have our project ready. Now I'm going to my account section. In here, click on security and I'm going to generate a token. So I will say episode 5 token followed by project analysis token, and I'm going to select the demo project which we created, episode 5 SonarQube project. Generate, and I'm going to copy this token. Now let's jump back to our repository settings, followed by environments. We have production environment, and we are going to add a new secret. So I'm going to give the secret value, followed by I will say sonar underscore token, then add secret. This is done. Now let's try to set up the actions. I'm going to use runners, and inside the runners I'm going to click on self-hosted runners, click on new runner and new self-hosted runner. I already showed this process, that's why I'm going it a bit fast. If you don't know this particular process, I created a separate dedicated video for this. Please follow that. I'll try to put that link in the description. I'm going to create a directory real quick. Now let's try to quickly set up our GitHub Actions runner. For that, I'm going to follow the exact steps which are provided on the screen. Creating the directory, followed by downloading the latest package, and then we are going to validate the hash key. I'm going a bit fast because I already explained about this particular process step by step. If you haven't watched, please watch that video. I explained everything in detail in that particular video. I'll try to put that link in the description. And finally, we are going to configure that. I'm going to press enter, enter, enter. I'm not going to give anything here, enter. Right, and then we are going to run this. So our GitHub runner is ready to listen to the jobs. Our GitHub Actions runner is ready. I'm going to refresh this page and I can see DevOps Lab. This looks perfect. And the reason we are using this particular self-hosted runner because our SonarQube is running locally. We are using a self-hosted GitHub runner, and also this particular SonarQube server is running on my own virtual machine. To keep this particular demo simple, I'm not using any kind of cloud environments or public networking, tunneling, and all of that stuff. I would like to explain more in detail about the actual problem and how to solve that. So let's jump back to our Visual Studio Code, and I'm going to open a new terminal. First, we are going to start with writing the application.py file. So I already created this particular folder as I showed you in the beginning. Intentionally, I'm trying to create this particular file. If you look at this application.py file, clearly it has three problems. Okay, one by one we are going to discuss. First problem is we are hard coding the secret key. The second problem is we have a debug endpoint again, which is returning the key. And the third, risky command execution using shell equal to true. But here's the dangerous part. The application will work. The container will also get built properly. The endpoint which we are trying to use here will also work. Nothing looks broken operationally, and also working code does not mean secure code. Followed by, let's try to add our requirements.txt file. As I said, I'm keeping it very simple. We did it in our previous episodes as well. Simple Flash dependency. And then we are going to create a Dockerfile. So Dockerfile, once again, I'm going to take it from my previous episode. It's exactly the same Dockerfile, and I'm going to write it down in this particular episode. Now we package the app as Docker image. Again, everything looks completely normal from a DevOps point of view. Now we are going to build this particular image using Docker build command. Press enter. Docker image got built successfully. Followed by, let's try to run that locally real quick. I will say docker run -rm -p port followed by sonar demo. This is running. So let's try to access that real quick. So I will say curl localhost 5000. I get the response saying production application is running. This looks completely normal, right? And also, before pushing the source code, I would like to run one more command. We have another endpoint called debug. Press enter, and you can see the problem already, right? Application is running, debug endpoint is also reachable from the outside. This looks like a successful deployment, but from a security point of view, we already have a problem. Now let's jump back and try to write our sonarcube.properties file real quick. So this is my sonarcube.properties file which I already created, and in this file I'm going to write our project key, which is episode 5 SonarQube quality gate, followed by we are going to write the project name, exactly what we have in the SonarQube server which we already created in the beginning, and I'm going to exclude these particular files and sonar.python version 3.12. This particular file will tell which project this code belongs to and where the source files are. Save this. Followed by, let's jump back to our workflows.yaml file. In here, as you can see, we are planning to create a bad pipeline. For that, I'm going to write the code and save this. Name here would be episode 5 SonarQube bad pipeline. Branch would be main branch, and then path here is episode 5 SonarQube quality gate /star folder we are checking, and the YAML file. Followed by, it is running on our self-hosted runner. Then run working directory is equal to episode 5 SonarQube quality gate folder. Environment is, let's say, production environment, and then checking out the source code, building the Docker image, and then running the SonarQube scan. So in here, if you see here, clearly we are writing as name SonarQube scan uses this particular action, SonarQube scan action version 4. Environment sonar token, which we added in our GitHub secrets. Sonar host URL localhost 9000, because it is sitting on the same server where our self-hosted runner is running at the moment. With project based directory is episode 5 SonarQube quality gate. Then finally, the last step is deploy to production. Can you spot the problem in this particular file? Let me know in the comments what do you think, and write it down before I tell about the exact problem. The pipeline is scanning the code, but it never checks whether the quality gate passed or failed. That means SonarQube is only reporting, it is not enforcing. This is where DevSecOps becomes security theater. Let's try to add the workflows file as well. Git commit -m followed by add workflow files. I tried to forget all the time. So yeah, now let's jump back to our repository. Now let's look at the actions and see what exactly is happening. So this is my episode 5 SonarQube bad pipeline, and it failed on SonarQube scan. So I see unzip command not found. All right, I will try to install it because it is my self-hosted machine. It is very simple. Sudo apt install unzip command. I try to install unzip. Let's look at the pipeline once again. The pipeline ran already and it failed once again. Let's see what's happening now. So I can see SonarQube scan, loaded plugins and all. And finally, I see an error. You are not authorized to analyze this project, or the project does not exist on SonarQube. Okay, please contact the administrator. So I am the administrator. Let's look and see what exactly is happening. So this is my episode 5 SonarQube uh, quality gate demo project, and I can see project information here, and I can see project key as well. I'm going to copy this key and let's verify with our sonar project.properties, and this is the key. Let me paste it here. Okay, there is some typo, I guess. Caps lock, small and capital letter, maybe that is the reason. So let's try to add that once again real quick. Git commit -m update sonar properties, git push. Now let's look at the pipeline once again. I see a green pipeline. Congratulations. Pipeline passed successfully. SonarQube scans successfully. If you can see, execution success. Now let's jump back and also try to deploy to production. Okay. Now let's jump back to our projects here and let's look at the result. If you look at the result very carefully, open issues 1, security. Okay. Maintainability 3 open issues, 1 security hotspot. Okay. Overall, I can see this particular analysis and quality gate passed successfully. First analysis, we have 4 issues, and let's click on this. Clearly it is, let's say, taking me to avoid binding the application to all network interfaces. Okay, and followed by we have other issues as well, some maintainability issues and also 1 security hotspot. Okay, directly it is like, let's say, taking here, make sure disabling CSRF protection is safe here. Okay, this is very high priority. So what do you think? Pipeline is green, deployment is successful, it already deployed to production, and SonarQube is, let's say, showing us so many different issues, security hotspot, and 3 maintainability issues. The tool worked perfectly, but the process failed. Now we add the missing control. Here I'm using the same workflow file, but we have one more extra step: SonarQube quality gate check. This quality gate check decides whether deployment is allowed to continue. Before, SonarQube was just a report. Now, SonarQube becomes a release decision. This is the difference between scanning and enforcing. Save this. Now, let's look at the quality gates in our SonarQube server. I'm going to click on create here, followed by let's try to add a name. Episode 5 strict DevOps gate. Click on create, followed by I'm going to add some conditions here on overall code security rating. So I will say security rating here worse than A. I'm going to add this particular condition, followed by reliability rating, again worse than A. Then I will say maintainability, again same, worse than A. Finally, we are going to talk about the coverage here, less than 80%, and then security hotspots reviewed, less than 100%. Once we have this in place, let's go to the project, click on the project and quality gate of the project. Here, always use a specific quality gate. I'm going to say episode 5 strict DevSecOps gate. Save this. It got saved successfully. Now, let's jump back to our pipeline. Here, I'm going to click on the actions. Click on episode 5 SonarQube fixed pipeline. run this particular workflow. Click on run workflow. Now look at the difference. Same code, same issue, but this time deployment stops. It failed near SonarQube quality gate check. Quality gate has failed. Detailed information can be found here. Now, this is real DevSecOps. Unsafe code does not move forward. Now, let's try to fix this real quick. Now we are going to replace the full version with a very simple version so that our pipeline will pass. I'm going to say git add followed by git commit -m, the message update python file, update application code, then git push. Now let's look at the pipeline once again. I see the pipeline is green. This flow looks correct now. SonarQube scan followed by we have a quality gate check. It also passed and finally we were able to deploy to production. This is the type of flow we have to follow. And if I click on my SonarQube server, here the project, everything looks green. No security spots, no security hotspots, coverage looks good, no duplications, one maintainability is there, that's okay. But overall, across this series, we saw the same pattern. So if I go back to my Visual Studio Code, we did 5 different episodes. First, infrastructure existed, but it was exposed. Then container existed, they were vulnerable. Kubernetes RBAC was too powerful. Then CICD existed, but debugging leaked credentials. And now SonarQube existed, but deployment ignored the result. The biggest lesson from all 5 episodes is simple. Tools don't secure systems, all your decisions do. DevSecOps is not about adding more tools, it's about making security part of your delivery. Because healthy systems can still be insecure systems. If you watch the full DevSecOps disaster series, comment DevSecOps. I'll know you are serious about real production engineering. Thank you for watching and see you in the next video.